Hi, and welcome to our second set of video lecture notes. The topic for this one is experimental design. So you should write that at the top of the page of your Cornell notes. And on the other side, you need to write the date so you can keep your notes in chronological order. First, we're going to talk a little bit about some terms. The first term we're going to talk about is a scientific hypothesis. As I mentioned in class, I don't like the term educated guess. This is because it makes a hypothesis seem too random and flippant, something that you just kind of came up with. I don't like the term guess being used for hypothesis. Instead, a scientific hypothesis is based on prior experience, scientific background knowledge, preliminary observations, and logic. So be sure to write the word hypothesis on the left side of your notes, and then write down a definition for it on the right side. Maybe also make a few bullets with some other information that you think might be helpful. So hypotheses are often supported by many different lines of evidence. This would refer back to your scientific background knowledge. And it's also an explanation for an observed phenomena. Here, phenomena just means something that you have observed in nature. Also a note that hypotheses and also theories and laws cannot be proven true. This is because science does not prove that things are 100% true, but anything in science can be proven wrong. So if someone's saying that something is 100% absolutely true, they're not talking about science. In science, we know that all the evidence we have at that time might best support something, but there's always the chance that we could come up with new evidence using new technologies that might help us understand something differently in the future. Our next word you're going to want to write down is scientific law. And in class, you guys often thought up words related to government and rules that must be followed. This is not what we're talking about here. So a scientific law is much less rigid. It may have many exceptions. It can be modified or rejected, and based on new evidences and perspectives. It's usually something that's generalized about data that's been collected, and it's a compact way of describing what we expect to happen in a particular situation. In biology, we often talk about Mendel's laws of inheritance. So if you've ever done a Punnett square, you're using Mendel's laws to try to predict what traits offspring might have based on what you know about their parents. This only works with certain traits. It doesn't apply to all traits and all inheritance, and that's why it might have exceptions or might not apply to all situations. A scientific theory is something that people often think about as a hunch, something that people think might be true. This is not the case in science. Theories have broad explanations for a wide range of phenomena, things that we observe. They're usually concise, coherent, or easy to understand. They're systematic, and they can be used to make predictions about many different sorts of situations. They're strongly supported by many different lines of evidence. So this is where you've had many, many researchers doing many different types of experiments over many, many, many years, and we have not yet found good evidence to show that it's not true. However, it may be modified or overturned if new evidence comes up. This is like what I said about hypothesis. Things in science cannot be proven 100% correct, but by the time it gets to the case of a theory, it's something that is as close to absolutely correct as we know, at the moment at least. So let's talk a little bit about data. In the last video notes, we talked about observations and how you can take quantitative or qualitative observations. So data is any kind of measurement you're going to take during an experiment. If we're doing quantitative observations, this is usually going to be reported visually as a chart or a graph. When you're designing an experiment, you need to know about your variables. So on the left side of your paper, be sure that you write the word variable. And on the right, write the definition, any factor that can change during an experiment. We also have two different types of variables that are important for you to know. An independent variable which is sometimes called a manipulated variable. This is the thing that you actually change in the experiment. And a dependent variable, or a responding variable. This is what changes based on your independent variable. So if you want to see what type of music will make plants grow the best, maybe you have a few different plants. They're all the same type of plant, but you're going to expose some plants to classical music and some plants to country music and see which ones grow the best. Music would be your independent variable, and particularly what type of music, classical or country. Whereas your dependent variable is going to be the thing that you're actually measuring, the thing that you think might change based on your independent variable. So in this case, it would be the size of our plant, or maybe you'd measure the mass of the plant and see which plants had the biggest mass. So in this example, with our music listening plants, our experimental group would be the group that receives a treatment or an independent variable during an experiment. So any plant that listened to classical or country music in our experiment would be in the experimental group. However, we also have to have something called a control group, a group that does not receive the treatment during an experiment. So this would be some of the same species of plant that do not listen to any music. So it's the absence of your independent variable. This is often used as a benchmark to compare the experimental group or groups to, and it's a way to look for error in an experiment so that way you know if something's gone wrong or if maybe you need to go back and take a look at what your hypothesis is, how you designed your experiment, but pretty much it's time to start troubleshooting if you see that there's something wrong with your control group. All right, so this is the end of our notes. Make sure that you go back through, you rewatch the video, and that you double check and make sure you haven't forgotten to write anything down. Just because I didn't tell you to write it down doesn't mean that you don't have to write it down. However, you should not be writing every single word on the screen. Make sure to write your summary at the end of your Cornell notes, and also don't forget to do your notes review questions. You're going to need to turn those in.